Hey guys, example 6 here, and if you thought that the problem in example 5 was cool, I think that this problem is even cooler. And what we have to do here is show that the sum of the x and y intercepts of any tangent line to this curve is going to equal k. What? Okay, let's slow down. So what we have to do is find the tangent line to this curve for any point, and then show that the x and y intercept of said tangent line are going to add to k. So the sum of the x and y intercepts of any tangent line to this curve has to have the value k. All right, so how do we start? Well, first, since we don't know our point, let's call it a comma b. So we're saying that our point has x coordinate a and y coordinate b. Now, the way we ensure that this point is on the curve is require that it satisfy the following equation, which is root a plus root b is equal to root k. And that way, again, we've guaranteed that the point AB is on our curve. But for all points AB that are on our curve, if we find their tangent line and then find the x and y intercepts of said tangent line and add them together, we need to have the value k. So now let's work on our tangent line. Now, in point slope form, our tangent line will have equation y minus b, y minus y1 is equal to m times x minus a. And clearly, implicit differentiation is going to come into play when we seek to find m, right? Now, m is going to be dy dx, but dy dx evaluated at a comma b in this particular case, right? So let's get to dy dx first. But let's, to start, rewrite our equation in a slightly friendlier form for the purpose of taking derivatives, which is, right, x to the 1/2 plus y to the 1/2 equals root k. And I don't care about the root k being written as k to the 1/2 because it's a constant either way, and as soon as we take the derivative, it's going to go away. Anyway, now we take the derivative implicitly and see that we have to write 1/2 x to the negative 1/2, right? And then plus 1/2, and then times y to the negative 1/2, and then times dy dx, right? Important, equals 0. And from this equation, we can solve for dy dx. And if we do, then we'd have to write the following, which is we have to write that dy dx is equal to what? It's going to equal negative 1/2 x to the negative 1/2. Guess I can show you like some intermediate step instead of just like jumping to the final result. But yeah, it's going to be this divided by, and then it's going to be divided by 1/2 times y to the negative 1/2. Now first, we can get rid of the 1/2s, right? This and this. They cancel into a 1, and it doesn't look like I'm canceling them. Got rid of too much. Okay, whatever, I'll live. Okay, canceled them. And then the x to the negative 1/2 could be made positive if we put it in the denominator, and then put the y to the negative 1/2 in the numerator and make it positive. So dy dx then will look like this. We still have this minus sign, right? So we have minus, and then it's root y, or y to the 1/2 divided by root x, right? Got it. Now, let's get rid of this. And get rid of this. And then move this somewhere up here, right? And we need to evaluate dy dx at a comma b, right? At a comma b, so that we can find the slope m at a comma b. And so dy dx evaluated at a comma b is going to be what? Sorry y'all. Vertical bar, I'm happy with that. A comma b. So that's going to say that at a comma b, dy dx is equal to negative root b divided by root a. And so this is the slope m that we were after. So now the equation of our tangent line can be completely determined. Well, assuming that we know a comma b, like in the more general case. So so we write y equals, and so I'm going to add this to both sides of this equation. But yeah, y equals, I have to have m, which is negative root b over root a, and then times x minus a, right? And as I said, I was going to add that to both sides of this equation, so I'll have a plus b here. Now, I want to simplify this more and get it like in slope-intercept form, basically. So I get y equals negative root b over root a x. And then this minus and minus is going to have us write a plus. And then we're going to write plus root b, right, times a divided by root a. But wait, this root a and this a there in the numerator can cancel, so that we just have a root a in the numerator. So we could just write root b times root a. But that's just root ab, right? So we could just write root ab. So root ab, and then that b, root ab, and then of course we still have plus b, and that's that b. Yeah, okay, cool. So there it is. That's the equation of our tangent line in point slope form. Yeah? Okay, cool. And now we get to write the x-intercept and the y-intercept. So let's start with the x-intercept. So x-intercept, if I just abbreviate as x-int, right? X-intercept is going to be the following, right? Which is x-intercept is like when y is equal to 0, right? As usual, x-intercept means y equals 0. So y equals 0 means we have a 0 right there. And so then, you know, since we have to solve for x once we set y equal to 0, we might as well move these guys to the left side once we've made y 0. So we'll have minus b, and I'm going to backtrack and write this as root a times root b. Somehow I think that will help us with the algebra that remains. Yeah, so minus root a times root b. And then on the right side, we should have, again, I've made y 0, and I've moved these guys to the left. So on the right side, I should have this still, right? Yeah, and so that'll say I have minus root b divided by root a times x, right? Okay, now I can multiply both sides of this equation so that I no longer have negatives. So I could just write root b divided by root a times x on the right side, and then change that to a plus and change that to a plus, right? Okay, cool. We're almost there. Now, to solve for the x-intercept, I should just multiply both sides of this equation by root a over root b, right? When I do, on the left side, I'll have b times root a over root b, and then plus root a times root b times root a over root b equals x. And again, I got here to what I just wrote by multiplying both sides of this equation here by root a divided by root b, right? Okay, cool. Now, this simplifies a lot, actually. And here's how it simplifies. Or it simplifies pretty nicely. Maybe not a lot. Okay, and this is how it simplifies, right? First, root b here and that b there could just turn into a root b in the numerator. So here we could just write root a times root b. So let's do that. And I'm actually going to write just root ab this time, and I'm pretty sure that I'm safe now. I'm not going to find any more algebraic conveniences by writing root a times root b instead. Anyway, here what we have is this root b in the denominator and that root b in the numerator are going to cancel, and I'll have root a times root a, which is just a, right? Okay, cool. So let's get rid of this and just write a, because that's what it all condenses to. All right, so we see that the x-intercept simplified a lot will be equal to this, right? All right, and now time to find the y-intercept. And we don't need this here, so let's get rid of this. And to find the y-intercept, it's pretty clear what we're going to do. And that is make x 0, right? So y-intercept, so y-int is x is equal to 0, right? And stay consistent. Okay. And so what is that going to say? When x is equal to 0, I'll have y is equal to, when x is equal to 0, and the equation to the tangent line here, right? This is x, and so when we make that 0, this guy goes away, and we'll just get y equals root AB plus b. So then the said sum of x and y intercepts to any tangent line, right, is going to say x plus y is going to say that we have a plus root AB plus root AB plus b. But wait, we can combine these into 2 root AB. So let's write a plus 2 times root AB and then plus b. And what we have to do is show that this is going to equal k. Question mark. Is it? And how are we going to do that? What about this? We said that if the point a comma b is on our curve, then it must abide by this equation. Now, let's bring this equation down and square both sides of the equation. And that's the only way we can get k out of it anyway, right? Okay, and actually, since I don't need the space here, let me get rid of that and slide it up there. And yeah, so what we're going to do is take this equation, which we know has to hold true, and then square both sides, and surely the right side will equal k, and hopefully the left side is going to equal hopefully the left side is going to equal 2 eager. That is it? Yes, it is, right? We get, if we square root a plus root b, we're going to get a plus root a times root b, and then another root a times root b, so 2 root ab, and then plus b root b squared, which is b, and of course on the right side is desired to get a k. Yeah? Cool. All right, I hope you enjoyed this, and there's one more example to come. Keep watching.